Welcome to AI with Sally, an EE Times podcast that brings you inside my conversations with luminaries of the AI chip industry. This episode is brought to you by our sponsor, Andes Technology. Today, I'm joined by Mark Evans, Director of Business Development and Marketing at Andes Technology. After years of hype, RISC-V is hitting a moment of truth. In 2025, we've moved from experimentation to execution. We've seen big players make some bold acquisitions, while startups on the scene have been facing commercial realities. The question is really shifting from what is RISC-V to who can actually make it work. In this episode, we'll explore what's driving that transition to execution and what it means for AI applications. Here's my conversation with Mark. Okay, Mark, welcome to the show.
Thank you. Thanks for having me, Sally. It's great to be here.
So we're going to talk about RISC-V today and kind of hopefully get a little bit of an update on where we are with RISC-V. Actually, a lot happened in the last year or so, or within 2025 for RISC-V and the RISC-V kind of landscape. I mean, we had acquisitions, we had pivots. Some companies sadly closed their doors too. Maybe let's start with, I'm keen to know what you think is the difference between a company that is succeeding in RISC-V this year or a company that's failing in RISC-V.
Yeah, and even the it has been 2025 was a really interesting year, and I think it's going to continue in 26. But even the companies that might have closed or have gone out of the RISC-V proper ecosystem, I'm not sure I see as failures. They've all contributed to the RISC-V community in meaningful ways. I believe what we're seeing is the natural maturation cycle of a technology going on, right? Early in RISC-V, there was a lot of excitement about it. A lot of new players had different ideas on how to leverage the technology. Those experiments have played out. They continue to play out. But, at the end of the day, it has to be commercially viable for a company to survive. And so the ones who are thriving in RISC-V, I'd say, have built their technology around commercial viability and customers that can actually ship silicon with RISC-V at the end of the day. Others who haven't been able to get into volume production, I think we're seeing get acquired, try to get acquired, or unfortunately having to close doors.
Yeah, I mean, even those companies that have, I think failed in inverted commas, but those companies have trained up RISC-V engineers and kind of put them back out into the market, I suppose. So that's a service in its own right, isn't it?
Exactly. The ecosystem, the evangelism of RISC-V, that has all, the entire community and the technology industry, I think, has benefited from them.
I mean, some of the acquisitions that we've seen look from the outside, or from my perspective, like talent is a big part of it as much as the technology. I mean, the big names in acquisitions, so Qualcomm, Ventana, and Meta, and Rivos. Mm-hmm. Do you think, how big a factor is talent in an acquisition like that? And is RISC-V talent really so valuable that it's reportedly $2 billion for Rivos? What's the price on this kind of talent today?
Well, so those are a couple of really interesting exits. I think so. RISC-V is a RISC ISA, much like any other RISC ISA. Right? It's got its own subtleties that I think are good. But in the particular case of Ventana and Rivos, those were high performance processor design teams, and whether the RISC-V nature of that talent is front and center, or whether it's acquiring in-place high-performance design team, which is a difficult thing to build up, right? So now you get the synergy of two things. You've got a high-performance capable design team that is already specialized in understanding the nuances in RISC-V, which allows particularly in the case of both Qualcomm and Meta, a lot of sovereignty. And Meta has shown through their MTIA development over the years that they're investing quite hard in RISC-V. And so Revos, I think, moves them one step further along that path.
Yeah, I think in kind of 23 and 24, it was a kind of companies were experimenting with RISC-V. And I think we're reaching the point where now we're starting to see actual products and actual execution. Is it just maturity of everything, or what's changed really to bring this execution phase in?
Oh, wow. There are so many things on the flywheel. And I've seen throughout my career a number of different CPU architectures come and go. I believe it's a combination of a number of things. Number one, the ISA maturity and the openness and sovereignty it allows is attractive, particularly in the last five-ish years of the geopolitical climates, right? But in parallel with that, a processor architecture can't succeed without a software base around it. And this is an area where I think a lot of the RISC-V community, RISC-V International, organizations like RISE, Andes as a company, and other companies have really invested in the ecosystem. And this flywheel is starting to gain speed of RISC-V getting into product, spawning more ecosystem software, enabling more product. So I think we're starting to see that flywheel really speed up right now.
So this space, kind of CPU space at both ends of the scale, is to some extent dominated by ARM. ARM, in AI chips, we talk about NVIDIA kind of as the gorilla in the room. For you guys, it is ARM. ARM, of course, been in the news recently because they're becoming a silicon provider as well as being an IP provider, which is a really interesting move. That's a whole separate podcast, but.
Yeah, it was a wonderful announcement the other day, and I'm actually really happy about it. Ironically, coming from the RISC-V area, you'd say, well, why are you happy about ARM, moving up and doing a data center CPU chip? I think a couple of reasons. One is, and I've listened to the overall talks throughout the day. ARM is clearly moving upstream. They've moved up from IP to CSS now to doing chips for data center. And, honestly, that is very competent, right? They are public companies. They need to provide shareholder value. They move into the higher value areas to do that. So I don't think it's nefarious in any way. I think it's just ARM being a competent company doing what a company does for shareholders. But the more they move up, the bigger the territory is for RISC-V to grow into. So I see it as when ARM wins and moves up into areas, RISC-V wins and moves up into areas. It helps everybody. And I also think that there was an interesting point on that where the data center TAM was expected around $100 billion, but there was a hint at a $1 trillion TAM for other chips, right? So it'll be interesting to see what markets this tries to go after next, whether it's automotive or AI accelerator or other areas. But there's really only two players, being AMD and Intel, in the CPU market for data center. So that's limited competition. But when you go after automotive, right, you now have a much broader competition base. So it'll be interesting to see how those dynamics play out long term, but I think they'll be beneficial for RISC-V.
Obviously, EE Times will be watching very closely.
Yes.
To what extent do you think companies are exploring RISC-V as a way to have alternatives to ARM, or to keep their options open, or even to put pressure on ARM? Like, to what extent is this about ARM?
The interesting thing is, I believe, and in the conversations I have with customers, I think there's one of two paths that customers start coming into RISC-V. One is pure technical differentiation. And we clearly see that in the AI domain where, customers are adding new data types, they're adding new operator types, they're accelerating architecture because the workload is moving so fast. And they're buying into RISC-V because it suits their needs technically. On the other end of the spectrum, there are the companies that for a number of reasons, are potentially feeling threatened, need more business justification, maybe that technical advantage isn't front and center in their mind, but it's more the sovereignty and the supply chain pressure.
Mm-hmm.
But what's interesting is even when the conversations start there, once they get a sense of where RISC-V can be advantageous, that also becomes an attractive factor. So I don't think it has to be one or the other. Oftentimes it will start out of a interest of how do I maintain, an alternative to ARM, or how do I keep pressure on my primary vendor? But then when you start the conversation, oftentimes you'll find little forks in there where the differentiation becomes valuable, and those become the initial adoption points.
Would you say more people enter through the path with the technical advantages, or are most people coming in on the path where they want options or strategic kind of independence kind of options?
Wow, that's a tough question. I think, using numbers from our 2024 year-end close, we had almost 40% of our revenue from AI proper companies. And I think the AI domain has spawned just a million different ideas and startups. And so by sheer numbers, RISC-V is ideally suited to those AI implementations and accelerators. So by sheer customer numbers, I'd say the technical value in that domain has been front and center. Almost all those guys are using RISC-V in some way, shape, or form. From the large established players, I think those generally come more from the how do I keep pressure on ARM or build up a strategic alternative. And long term, I think that's going to represent, more revenue dollars.
Yeah. It's interesting that you say most AI chip companies or AI companies are looking at RISC-V or are involved with RISC-V. So on this show, because it's about AI chips, we talk about AI chips all the way from the data center all the way to the edge. We do speak to a lot of RISC-V companies, but does RISC-V really fit into all those niches? I mean, data center, yes, we have a few playing in that area, but all the way down to the micro NPU as well, like everywhere.
We do see it, and we have customers across the spectrum. So some of our announced customers, obviously, Meta in the MTIA, clearly in the data center, and a great example of this co-design of hardware with workload. There was a recent blog on Meta's site by YJ Song talking about high velocity iterative design, right? Where they're doing 4 MTIAs in 2 years, right? So great undertaking there. D-Matrix also going after data center inference. We have one of our customers is Accelera, who is more on, I'd say, the premise edge sort of area. And we have 3 or 4 customers. One is called Tetramem, a few others down at the microwatt sort of level of, detecting something, doing sensor sort of AI. So the configurability of RISC-V allows you to tune the single architecture to the workload, and it does expand, does span a very wide range.
I'm curious about which of these markets is adopting RISC-V the fastest. It seems like more embedded companies are coming to RISC-V quicker, but is that just because there are fewer data center companies? Like which niches are going faster into RISC-V?
Well, so broadening beyond AI, I would say the embedded markets, and this could be anything from, Bluetooth hearable sort of devices, into network communications, and even, we have customers doing small cells and base station on a chip designs. So I would say embedded is definitely the probably where the volume is and where the largest penetration is. Data center in the accelerator front is probably where the largest designs are taking place in the data center. One of the dynamics for that is the software ecosystem is, evolving quickly. But in designs where you can own your software and you have control over your software footprint and you don't have to run every app du jour out there, RISC-V is sufficient and ideally suited and getting more capable every day.
For AI, I mean, we spoke about customization and the technical benefits just now, but most AI customers are customizing the ISA, right?
They are. Yes, they are. Absolutely. We see that firsthand. We offer a set of customization tools that make that straightforward and pretty much foolproof for customizing the ISA. And I would say probably all of our AI customers are making fairly extensive use of that.
One of the applications I wanted to ask you about was automotive. Automotive is really specific in terms of requirements. Yeah. They have really tough technical requirements when it comes to things like functional safety. Can you tell us something about RISC-V and functional safety? How far along are we with that?
Yeah, I think that's going to be a little more vendor dependent on RISC-V. So I don't see there's an automotive safety qualification for an ISA. It's usually, it's a qualification for a particular implementation that eventually makes it to a vehicle level safety qualification, right? And so as we go and implement RISC-V, we have to do a lot of work to make sure our RISC-V cores are safety compliant. And that stems back into how you develop the product. So we have to go, and we've done a ISO 26262 systematic certification, which certifies our process is correct for functional safety. And then we design products, RISC-V products within that process, and then go get those products certified so that they meet all the safety requirements and needs for that. So that's generally the process. I think we're going to see, RISC-V has a lot of interest from automakers. A lot of the big guys have formed a company called Quintaris, which is a great partner of ours, and they've built up some nice demos using RISC-V, certified OSs, certified tool chains to build kind of a real-time reference platform. We're proud to have a few of our cores in that platform.
So again, I mean, going back to ARM, they're very successful in automotive and have been for a long time. Are we at the stage where OEMs and tier ones are looking at RISC-V as a first choice, or are we still at the stage where we're just like a second option to ARM?
That's a good question. I think there are areas in the automobile where RISC-V will quickly become the first choice, particularly in AI functions where it has a natural fit. And in physical AI domains where real time from sense to decision to actuate is fundamental because you can tune your RISC-V and your software specifically to the workload you need. When you get to more of the IVI functionality and infotainment, that's more of an app store type environment. So I think that's going to be a longer term objective.
Okay, in terms of technical milestones, I know the RVA23 profile, when that actually came in 24, I think, but that because that had vector extensions in it. I know that when that was finalized or ratified, that was a huge milestone for RISC-V. I know this is something that chip companies had been waiting for as well. How important are these types of technical milestones when it comes to commercialization?
So RVA23, I think, was probably, so vector extensions and RVA23 were probably the two big milestones. RVA23, what we saw with that was quickly more of the software ecosystem was satisfied that they had a compatibility base to wrap around. In particular, Android and NVIDIA announced CUDA support for RISC-V, right? So I think the biggest leverage of this sort of standardization is to give the software ecosystem confidence that they will have vendor independent but compatible targets that they can use for their development. So from that perspective, I think the standardization is highly required.
What does it actually take to ship a commercial RISC-V based product today? Like, what are the biggest hurdles or biggest challenges companies are still facing?
Wow, that's a big question.
Yeah, it is.
So, first of all, um, even when ARM, when companies way back when started shipping ARM, right? I think there were similar challenges. Does the IP work, right? Do you have something that you can incorporate and rest assured it works? I think we're at the stage where, we have good IP for RISC-V, rock solid IP. Customers can take it and they know they're going to get, production worthy chips back. The second question being the things around the IP that you need to build a chip. So NOx and debug infrastructures. And those are, we have a great partner ecosystem that fills those needs. It's still at the customer needs to understand what they want and sort of assemble the pieces. And that I think will continue to move upstream a little more. And then finally, the software that's going to run on it. And certainly in the cases where customers have good control of their software, that's a solved problem. The open app environment, that is one that is moving forward quickly. So I think the ingredients are there. We're seeing certainly in a lot of markets, good adoption, deployments, and shipping. We have crossed 19 or 20 billion SoCs shipped with our IP so far. So it's got traction, but I still think we're at the very, very knee of the curve on this one.
Okay, so Andy's is hosting an event in Silicon Valley this April called RISC-V Now. This is going to be in San Jose. This is a little different from what you've done in previous years. Tell us about what's inspired the change in name.
Yeah, so Andy's has conducted RISC-V conferences for probably 5 years now. We used to call them RISC-V Con. RISC-V Now, this is a mark of the inflection point of RISC-V commercialization. And what we're doing with RISC-V Now is really marking that moment and changing the nature of the show and expanding it to the commercialization lessons that our customers and our ecosystem has learned. So I'm starting to review some of the presentations that our customers are giving and our ecosystem is giving at this conference. And I'm really encouraged because they're honest engineering looks. They're not hiding the challenges they faced. So for somebody who wants to learn what it really takes to put RISC-V into production, we're hoping to give a very realistic view of that at this show, both the good, the bad, and where you might need to put a little extra effort you hadn't anticipated. I think there'll be more good than the others, but we want people to learn an honest view of that.
So being about commercialization specifically, this is a slightly different focus to RISC-V Summit as well, right?
Correct. RISC-V International is wonderful. They're a wonderful partner. We're a founding and premier member. The RISC-V Summit is a great venue for the ecosystem to gather. Specs and standards. A lot of meetings happen there. They get evolved. So we look at what we're doing as really a complementary effort on that.
So, okay, if people are listening to this, who is it really that should be attending? Engineering level, managers, everybody interested in RISC-V? Who's going to be there?
I would say even if you're not interested in RISC-V, you should probably be there just to learn about it. But our general audience is engineering heavy and, executive heavy. So if you are developing products, doing architectures, trying to understand how your software will fit onto a piece of silicon with a CPU. If you're a product planner and need strategic technology, I think this is a good show to get a feet on the ground view of what customers are really doing with RISC-V, and their experiences, more importantly, their experiences in putting it out into the field.
Okay. Someone's listening to this and they want to find out more. What's the website? Yep.
www.riscv-now.com.
Amazing. Thanks so much, Mark. I really enjoyed the conversation.
Yeah, thank you. It was good fun. I appreciate it.
Thank you so much, Mark. This episode of AI with Sally was brought to you by Andes Technology. Thank you very much, Andes, for sponsoring us. If you want to learn more about Andes Technology or the RISC-V Now event, please check the links on the podcast page at eetimes.com. That brings us to the end of the episode. Please tune in again next time for more conversations around AI silicon and systems. If you're listening to this on the podcast page at eetimes.com, links to topics we've discussed are shown on your left. AI with Sally is brought to you by Aspencore Media. Thank you for listening.